In this video, we're going to talk about the concentration of a solution. A concentration of solution tells you how much of a solute is dissolved in a solvent. So if we have a cup of salt water, and we're talking about aqueous solutions, we have water in here, and that is going to be our solvent. Water is known as the universal solvent. When we add in NaCl into here, that is going to be our solute. Our solute is dissolved into our solvent to make a solution. So when we talk about concentration, we're talking about how much of a solute, this small quantity, is found within a solvent of a solution. And to measure that concentration, we are going to use a unit called molarity. Molarity is defined as the moles of a solute divided by the volume of the solution in liters. So if I have a 1 molar solution of NaCl, of salt water, I should have 1 mole of NaCl in 1 liter of the solution. That's what that means. Or if I have 4 molar solution, I would have 4 moles in 1 liter. So let's do an example here. We are going to dissolve 24.2 grams of sodium chloride in enough water to make a 20-liter solution. And we want to know, what is the molarity of the solution? Okay, so let's first write out what we know. We know that the mass of NaCl is 24.2 grams. And we know that the volume of the solution that we're making is 20.0 liters. And we want to know, what is the molarity of the solution? Okay, so we know that molarity is measured in moles per liter, and we have grams. So we know that first we are going to have to convert grams to moles so that we're in the right unit. Okay, and to do that, we are going to divide by the molar mass of sodium chloride. So 24.2 grams, and if 1 mole is equal to 58.44 grams of sodium chloride. And when we do that, we get 0.414 moles of NaCl. So now we are taking those, we've put 24.2 grams or 0.414 moles of NaCl into 20 liters. Okay, remember our molarity is equal to moles per liter, so 0.414 moles in 20.0 liters is going to give us 0.0207 molarity. So that would be the concentration of our solution. Okay, so sometimes we are going to have electrolytes that are going to break apart in solution. And so here we're looking at copper nitrate. If we write this out, we have copper nitrate. When it is dissolved in water, we are actually going to get copper 2 ions, and we're going to get nitrate ions. However, we get 2 nitrate ions when it dissolves in water, because we have 2 of them bound to copper. So remember, you'd have copper 2 plus out here, and then you're going to have an NO3 minus and an NO3 minus. That'll balance the charges. And so this complex is actually made up of 2 nitrate ions and 1 copper 2 plus ion. Okay, so when it dissolves in water, we're actually getting 3 ions. We get 1 copper ion and 2 nitrate ions. Okay, so we have a 0.5 molar solution of copper nitrate, which means that we have 0.50 moles of CuNO3 Now, when it breaks apart in solution, we are going to actually have 1 copper 2 ion and 2 NO3 ions, okay? And so we are going to have 0.5 mole of copper 2, but the concentration of NO3 is we get 2 NO3s for every 0.5 or for every 1 mole of copper nitrate. And so we actually are going to have, well, we have 0.5 moles of Cu2 plus, we are actually going to have 2 times 0.50 moles of of nitrate, or give us 1 molar concentration of the nitrate ions, because for every mole of the molecule that we have, we get 2 moles of nitrate ions. Okay, so that's something you have to take into consideration when you're working with electrolytes, is that you actually are looking at how many of the ions you are forming. And we are going to write it out like this. If you use square brackets, that square bracket indicates a molar concentration. So if you ever see me write concentration of HCl, that's talking about molar concentration. It's a shorthand that you should learn. Once we know the concentration of a solution, we can make different concentrated solutions based off of that one solution. Sometimes I think of this as lemonade. So say that you are having some friends over and you make some lemonade using your lemonade powder, and you pour the powder in and you make it a certain concentration. It has a nice amount of sugar and a nice amount of tartness and everything in it. But then you decide that you're going to invite more friends over and you actually need more of the liquid. Well, you've run out of the powder, so you're just going to add more water into the solution, into the lemonade. That's going to make your lemonade diluted, or a lower concentration. And so that's the same thing that happens in the chemistry laboratory. So we have a concentrated stock solution, a solution that's really highly concentrated, has a lot of moles per liter. And we use that we keep it as a stock, and from there we dilute it to make different solutions of desired concentrations. And so you're not changing the amount of solute, you're only going to be changing the volume. It's like adding more water into the lemonade. In order to calculate these concentrations, we're going to use the following formula, which is the molarity of your stock solution times the volume of the stock that you're going to use is equal to the molarity of your desired concentration times the volume that you desired. Oops. Okay, we can also write this as M1 V1 equals M2 V2. And here we're talking about molarity. So remember, this is molarity, which is measured in moles per liter. Okay. And so what we do is we use these tools that you can see over here. These tools here, this is called a volumetric flask, and this might be your stock solution. So this is your stock solution that's highly concentrated. Stock solution of, let's say, 16 molar, okay, very highly concentrated. And you want to make a solution that is just like a lower concentration so that it's not so strong. 0.10 molar is your desired concentration that's desired, okay? And you need 1.5 liters of that concentration. You need 1.5 liters. Okay, so we have a stock solution of 16 molar. So our molarity of the stock is 16 molar. And our molarity that we desire is 0.10 molar, and we need a volume of 1.5 liters. So we're asking, what volume of the stock solution do we need to take out of this stock solution and transfer into this volumetric flask so that we can bring the level up to 1.5 liters and have a 1.5 liter solution that's very, very diluted. So what volume of the stock solution are we going to need? So we put this into our formula, 16 times V1 is equal to 0.10 times 1.5, and you're going to get your volume to be 0.009375 liters. Now that's not really a volume that makes sense to me, so I'm going to change this into milliliters. So 1, 2, 3, and we get 9.375 milliliters is what we're going to use of this stock solution. We'll take 9.375 milliliters. We will take it out of the stock solution. Let's take it out of this stock solution and we will put it into this volumetric flask. It'll sit in this flask, and then we will add H2O to bring the level up to 1.5 liters. And then we will have the right solution.